AB Calculus Note Card 48, Riemann Sums equal width. This is the 48th video list in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District. This is the first one that delves into the initiation of what we call integral calculus. The note card videos 1 through 47 really go through the basics of differential calculus. So here we go with this. Let f be continuous and non-negative on the interval from a to b, then a Riemann sum estimates distances, area, total cost, etc. by sums of areas of rectangles of n subintervals called partitions or subintervals. I'd like to add something here. It says, we would say if f represents a rate, represents a function of a rate, then a Riemann sum estimates distances, area, total cost. So if we had, for instance, a rate of miles per hour, and we go ahead and take the graph of that and estimate the area based on the sums of rectangles, then we have found the distance covered by integrating the rate. That brings in the definition of integration. To find the Riemann sums where the n's are equal or the intervals are equal, we have the n is the number of blanks, and you are separating each blank by a plus sign. And then if we have the same height, so we're going to just see what this looks like. Okay. Set up an estimate of the area between the curve g of x and the x-axis using the right Riemann sums with 4 subintervals of equal width for the closed interval from -2 to 2. And so we have an interval from x equals -2 to x equals 2. And the way we say this for the estimate of the area, and what I recommend doing is taking the original language, in this case estimate, so we'd say estimate of, we make an integral symbol with our boundaries of integration from -2 to 2, and the curve is g of x. We'll say g of x dx is equal to, and then for 4 subintervals, this clues us into 4 blanks separated by plus signs. So we're already told what to do. And then we want 4 subintervals of equal width. And so here we have between -2 and 2, 1 subinterval, another subinterval. Now I'm drawing here along the x-axis. Okay, 3 subintervals, and finally 4 subintervals. So 1, 2, 3, 4. And each one of these subintervals, which will eventually become a rectangle, has a width of 1. So I'm putting the height of a rectangle. When you're talking about equal width, that number is going to be the same for all spaces. And we want to take a right Riemann sum. What we do out of this is go to the right of this first interval, and we come straight up here to the curve. Okay, we have created that, and then we make from that a rectangle by going over to the left. And so we have this rectangle that we've created. And then we go to the second rectangle here. So we come right up to the top, like we did in the prior rectangle, and go over like this. Okay, so now we have a second rectangle. And then we take our third interval, go right up to the graph and over to the left. And here we have another rectangle. And finally, for this last one, we come right up here and go over to the left. So we have 4 areas. And the 4 areas, we already have the height. You see it says the height of the rectangle. You see that each blank has a height, delta x. So delta x is going to be that 1 in each case. So the 1 in this case represents the delta x, right? Every one of these is 1, and so on. Delta x, delta x, delta x. Okay, and now the height of the rectangle, we say, okay, this first one here looks like we're going up to 2.5. And the next rectangle, we go up to 4, it looks like. So these are the heights we're putting in place here. The next one looks like we're going up to a height of 1.5. And the last one, we're going up to a height of about, it looks like maybe 0.4 or so, or we'll call it 0.5. And so that's it. And we can add these together if we want to get one number for that. But that would be an estimate of the integral from -2 to 2 of g of x dx. That's how we do it. Now we mentioned a right Riemann sum. A left Riemann sum would go up to the left side and go like this. It would create this type of rectangle, and then this one here, okay? And we're going to see examples of that situation in the future. Okay, 2, the rate at which oil flows out of a pipe in gallons per hour is given by a differentiable function. Again, this is going to be the rate. And so the integral of rate equals amount. And so we're gonna see that here. So we have use a left Riemann sum. So it says to approximate. So they're using the word approximate. So approximate of, and again we have the interval between 3 and 12. So this becomes our, remember we had this over here, the interval from A to B, remember that? So we're going to call these we're going to call these A and B respectively. Okay, and here along the table A shows up here at 3 and B at 12. So we're going to go from 3 to 12, and our function, our rate function, is going to be R of t dt is equal to, and we see we have between 3 and 6, we have one interval. Between 6 and 9, we have a second interval. And between 9 and 12, we have a third interval. So 1, 2, 3. So that means we're going to put 3 blanks separated by 2 plus signs. And then it says to eliminate the rate, you need to integrate. So we have a rate that oil flows, and it's going to be in gallons per hour. So that the integral of rate is an amount. So we're going to have a number of gallons, okay, after we've integrated the rate. So that's our units. Now we look at the delta x. It looks like we're 3 apart, every one. So we put our delta x right here, 3, 3, 3. And then we're going to find the height of each of these rectangles. And we're using a left Riemann sum, left. And so we go to the left. So the 10.8 would be on the right of this first interval. We take the left, which is going to be 10.4. And then for this next interval between x equals 6 and x equals 9, we put 10.8. And lastly, this third interval, our right side of that rectangular height would be 11.4, but the left one, which is what we're going to use here, is 11.2. And that's it. So we just check everything to make sure it's right. And then we go on to problem number 3. Suppose a car has the velocities, and again, what are we talking about? A rate in feet per second. So if we're in feet per second and we're using a Riemann sum to estimate an integration, we know what our amount is going to be already. We're going to look for, our answer is going to be the number of feet. And you could say feet traveled. Okay, there's one way you could say it. Find the estimate. So again, we say estimate, and we're mirroring the language here of, and we set up our integral from 0 to 12. So that'll be 0 will be our A, 12 will be our B. So we say 0 to 12. And then we put the name, the function by name, which is v of t dt. And it's going to be equal to, now, midpoints of 3 rectangles. And so what we're looking for midpoints of 3 rectangles, we're looking at the rectangle that comprises these data points here. And the next rectangle is going to be this one here. And the last one is going to be this one over here. So these are the 3 rectangles that we are going to compose. And again, since it says 3 rectangles, we just go ahead and draw 3 blanks, separated by 2 plus signs. Okay, this is a characteristic of Riemann sum equal with, that we have delta x be the same. In this case, we're going from 0 to 4, from 4 to 8, and from 8 to 12. So our delta x is going to be 4. Now for the height, we're looking for a midpoint. And what that means is we take the mid height. And so in the case of the first blank, we fill in a 30, because 30 is the middle value. And then for the next blank, we're going to fill in the middle height of this set of values, which is going to be 44. So we're not talking about a left one, we're not talking about a right, we're talking about a mid. And then finally, for the last blank, we're going to fill in the mid value here, which is 35. And what is this going to give us? It's going to give us the number of feet. And we could say feet traveled during 12 seconds, okay? In 12 seconds. So this is just our introduction really to Riemann sums, and we can improve our accuracy by getting more data points and by using types of methods that seem to be more accurate indicators. And we're going to be going into the next lesson, which is going to be 49. Is going to go over Riemann sums with unequal widths. I hope this has been helpful to you. Good luck, and thanks for viewing.